It's Megan. So I'm going to help walk you through the homework. You can do it intuitively, but I found Dr. Jensen suggested to help you work through these keys and make a phylogenetic tree. So for the first one, I'm not going to run through this one, but we can use the same principles I'll show you in this more difficult one and apply it to this one. And of course, as always, if you have any questions on your homework, you're welcome to come to my office hours and also go over your test as well. So for this one, we are looking at X as the outgroup. And so that means that it doesn't share a lot of traits with the in-group, which is everything else. So H all the way down to the O would be considered the in-group, and X is the outgroup. So we're going to compare the in-group to the outgroup. We look at X and we see, okay, it has a nucleotide A. So that means that I is the different one because everything else is A. So I is distinguished by trait 1. And so you'll go down and you'll highlight all the differences from the outgroup. So for example, number 2, the species that are distinguished by trait 2 are going to be H, I, and M. You see that? So they're different from C. And you'll continue this all the way down the line. So including 10 and, for example, 10, you're going to consider all of these distinguished by trait 10 and the outgroup not having trait 10. I think in Dr. Jensen's key it says you can't tell where to put 10, 11, and 20, but don't think about that. It turns out in the video she clarifies that mistake. Okay, so let's walk through this. I'm going to see if I can highlight these so it's easier to see. Oops. All right, so we'll highlight each trait that differs from the outgroup. That's our first step, because these are going to be the traits that distinguishes these species from the outgroup. And they're going to be our synapomorphies that allow us to be able to tell evolutionary relationships. All right. And for example, in 10, we're going to highlight everything that is different from this G. And intuitively, you probably wouldn't be able to tell where these go, where trait 10 would go in a phylogenetic tree, but using this method, you can definitely do it. And you feel free to skip ahead if you don't want to watch all of this. Alrighty. So now after highlighting all those distinguishing characters, we're now going to see if we can see some relationships. And remember, synapomorphies are the things that are the most useful to be able to tell if two species are related. So if species share some common traits, that must mean that they are somewhat related or share a common ancestor. Unless, of course, they're analogous traits, and we'll get to that part of the tree. Okay, so for this trait, for species I, it is distinguished by C, but it doesn't share that difference with anything else, so it doesn't really tell us much about its relationship to everything else. So on my whiteboard, I'm going to put I and trait 1 as it being distinguished by it. And we'll put that off to the side, just like that. Okay, so let's look at trait 2. Well, it looks like trait 2 is shared by H, I, and M. So we're going to put those in a little group. We'll write H, I, and M in parentheses, and then we'll assign it trait 2. And I'm hoping that this isn't totally backwards, but either way, you might be able to understand what I'm writing. Okay. So, moving on to trait 3. It looks like J and O share those distinguishing characteristics. See these two A's? So, J and O isn't on our board, so we're going to write it next to it. J and O goes over here. Joe. Okay. Then trait number 4, let's look at it. O. So it's just O that has this distinguishing trait. So we don't really understand any sort of relationship there, so we're just going to write O off to the side. And then a 4 right next to it. And feel free to skip ahead if you feel like you're kind of getting this process, but you can also go through the whole thing with me if you want. All right, trait 5. That is going to be K and L. So K and L, they share these traits, so they must be in a group. Let's see if we have K and L. We don't, so we need to make a new group. K and L, and we'll put it in parentheses. There. So it's kind of like a little equation for those of you who like math, and I don't. Okay, so trait 6, that is shared by H, I, and M. Okay, so we already have that group, H, I, and M. So we are going to put the trait 6 right next to trait 2 because it's just more evidence that these are related, that H, I, M are related. Oh, and I also need to put the traits that distinguish J and O and K and L. So J and O is distinguished by trait 3. So we'll put that there. K and L is distinguished by trait 5. That's right. All right, so we're moving on. Trait 8. Trait 8 is only shared with, it's not shared with anything, but H does have it. So that's not really helpful in figuring out relationships. We're going to put it off to the side and deal with it later. All right, number 9 is shared by H, I, M, and N. Okay, so we have a group H, I, M over here, H, I, M, but we need to also include N. And to do that, we're just going to write N next to our group and make it part of an even bigger group. Like that. So we have N right here, and we included it with HIM in this group here. Sorry, I'm working in a mirror basically. Okay. So what distinguishes this whole group here is going to be trait 9, and we'll put that on the outside of the parentheses so we know that it's distinguished by trait 9. Okay, and number 10, it looks like everything shares that, so we'll come back to that later. I'll highlight this one so we make sure to look at it. Okay, I think I highlighted it in blue. Trait 11 is also shared by everyone, so we will highlight that too, if it will let me. Okay, we'll come back to it. Oh, I actually got it to work. All right, trait 12. Trait 12 is shared by H, I, and M. All right, we already have that group. We just need to make sure we put the number in the right place. So number 12 is shared by H, I, and M. That is additional support that these groups are related. All right, and number 13 is not shared by anything. It's just M that has that trait. So we will put that off to the side and say trait 13. Like that. Okay, moving on to trait 14, that is shared by I and N. Okay, that's a little interesting because even though I and N are in this bigger group, they're not right next to each other, and that could be something funky. So let's not do anything with that. Let's put that off to the side until after we build our tree. If they were right next to each other, that would be a different story. All right, and that's trait 14. Trait 15 is shared by H, I, M, and N. Okay, so that's more proof that this whole group is related. So we will put 15 right next to that 9 there, like that. And moving on, trait 16 is shared by H, I, J, M, and O. Okay, so somehow these two groups are related. So to display that or show that, we're going to combine these groups into bigger brackets so that we know that they're a big group. So we'll do brackets here, show that these are a group, and the trait that distinguishes this whole group is trait 16, sorry. Trait 16, like so. All right, and trait 17 is shared by J and O. So that's more proof that J and O are closely related. So we'll put a 17 right next to our 3. Trait 18 is shared with K and L. All right, K and L, that's over here, so we need to just add that trait onto that. Trait 19. Trait 19 is shared by H, I, J, M, and O. Okay, so that's this huge group here. So we'll just add 19 right next to the 16 because it's further proof that these are related. Trait 20 we don't want to worry about now because everything except the outgroup has it, and that won't tell. All right, trait 21, everything has it, so we imagine that's going to be at our root because everything has it. And the root is the beginning of your phylogenetic tree that includes both your in-group and your out-group. Number 22, just J has it. Okay, so we should put that off to the side since that doesn't really tell us very much. Trait 22 is with J. Trait 23 is just with L, so we're going to put that off to the side as well. Okay. Trait 24 is shared by K and L. All right, that's over here. So we can just write 24 right next to it. That's super easy. 5, 18, and 24. And 25 is just K. So we'll write that off to the side as well. All right, so this is what it should look like. It kind of looks like an equation, but not really. I mean, not quite. And now we're going to use this to build our tree. So let's look at those traits that we highlighted earlier. These super important ones, the 10, 11, 20, and 21. We'll want to highlight that one too. Okay, so 21 is, so if you notice here, Alright, so we're going to have our root here. We'll start that out there. So I'm going to have to write pretty small because this is a teeny whiteboard. And we'll put our trait number 21 right there. And then you're always going to assume that the tree is going to split in two. So go ahead and draw a branch where it splits in two. And there's other formats you can use. You can do phylogenetic trees, but just make sure that you have traits along your branches, and there's two splits. Okay, so looking up here, what two groups can we make? What are the two groups that split off first? Well, it's going to be K and L from this whole big group. You see how these are two chunks that we can visually see? So this group here is going to diverge into K and L. And let's put this a little higher. So we'll bring that all the way down. And K and L is distinguished by 5, 18, and 24. So we will put those traits along this branch. Okay, and then we have this big group, and it's distinguished by 16 and 19. Oh, sorry, I forgot some traits. Remember back on this, looking at the PDF, so we need to include traits 10, 11, and, where is it? 10, 11, and 20. So we actually need to do this first. I forgot our out group. So this will be our out group. This is our X, and it doesn't have any distinguishing characters because we used it as our baseline. So we bring it all the way to the end. And then up here we're going to have traits 10, 11, and 20 because those distinguish our in-groups. See how all the in-groups have it but not the X group? So we'll put 10, 11, and 20 here. Alright, and then we're going to split this guy. So this is our in-group here. We can break it into two pieces, and those two pieces are going to be this KL group and this HIMNJO group. Alright, so we have our KL group, which I'm going to put over here. And it is distinguished by traits 5, 18, and 24. So we'll put those along the branch. Okay, and we need to completely split this one. Alright, so continuing on to our K and L, since it's such a small group, we might as well just keep going. So we'll split this in half, or we'll diverge this common ancestor here. Speciation event has occurred, and we have K and L groups. Alright, and we'll go back to plugging these characters in, and so these will end up having some characters on them. Alright, so going back to this group. Now we need to break this into tiny pieces. So the next split for this one, because we know it's going to split in two, is these two groups, HIMN and J.